So if you look at this equation, xy plus 5 equals 0. That doesn't look like anything we know. However, all our equations are y equals 2. So let's try to solve it for y equals 2. So it looks like something we might know. Okay, to solve for y, what do we have to do first? Sebastian, you're going to count to 5 from now on before you answer. Okay. What is the first thing you do?
Subtract 5.
Okay, good. Subtract 5. So xy equals minus 5. Okay, what's next?
Divide x.
Okay, good. Sorry, I'm laughing because I think I realized the problem. Everyone's just like, Sebastian's going to answer anyways. So I'm going to just sit tight and wait for him. And now that Sebastian can't answer, everybody else is like, I know the answer. Okay, anyways, so this is the equation, and we're not going to analyze this because this is kind of the same thing you did on the homework. I just wanted to show you how to change this equation into something you know. All right? Okay, let's do the stuff today. This is, we're getting to very important stuff. Okay, continuity. This is a very, very big thing that's going to go throughout all your math life. Okay, continuity means, can you trace this graph with your pencil without lifting your pencil from the graph? Okay, so let's go ahead and draw some XY axis. All right, continuous. So I'm going to draw a continuous graph. Continuous graph looks like this. Basically, you just draw it without lifting up your pencil. Okay, so just draw this graph without lifting up your pencil. This is called continuous. Now, if something is not continuous, it will be discontinuous. So we have two kinds of discontinuity this year. First kind is non-removable kind. So this graph looks like this, which is the ones you've been graphing, this way and this way. So basically, it is discontinuous because I have to draw one, take my pencil off, and then draw the other one. So it breaks. Okay? And the, what is it called? The characteristic of non-removable is that it has asymptotes. Okay, non-removable means asymptotes. Okay, removable. Removable means that you can temporarily remove this discontinuity. This graph looks like this. Half of it. And it's going to continue, but there is a gap in between. And usually we don't draw graphs with a gap in between. So what we actually do is we put a circle to indicate that there is a hole. So holes means removable discontinuity. Okay, so graphically, this is how you can tell. Continuous means you can draw this graph without lifting up your pencil. Discontinuous means you cannot draw this graph without lifting up your pencil. And there are two kinds. One is non-removable, which means there's asymptote, and removable means there's a hole. Now, if you look at the equation, how can you tell if something is going to be discontinuous? It is whatever makes the denominator undefined. So we're going to do a lot of denominator issues. So when the denominator is undefined, we will have discontinuity. We also call these the points of discontinuity. Okay, so discontinuity is caused by numbers in the denominator. And we also call these values of, these values are called points of discontinuity. All right, so let's look at these examples. This first one is non-removable discontinuity. Looking at this function, what x values make this discontinuous? 1 and -2. So 1 and -2 are points of discontinuity. And we're going to figure out if they are non-removable or removable later. Okay, let's look at the next one. Where are the points of discontinuity? X equals what? 1 and 5. What about 3?
No, because that's on the top.
Yeah, numerators, we don't care about numerators. This one. Where are the points of discontinuity? What do we have to do first? We had to factor. Anything in the denominator or anything in the numerator, we had to factor. So this becomes x minus 1 squared. So then where are the points of discontinuity? People are so quiet. 1. Okay, so we make sure you factor first. Okay, next, removable discontinuity. Removable discontinuity is caused by when a factor in the denominator cancels with a factor in the numerator. This discontinuity is temporarily removed. We call this a hole. Alrighty, let's look at this example. Okay, again, removable discontinuity is caused by when the factor in the denominator cancels with the numerator. Okay, so let's look at this first example. First of all, where is the point of discontinuity? What x values make this undefined?
-1.
-1. The next thing is this removable or non-removable? Removable because it cancels with the numerator. If it cancels with the numerator, this is called the removable discontinuity. All right, let's try another one. Okay, this next one. What do you have to do first? Factor. All right, so let's have you guys factor. You're going to talk with your partner about what are the 2 points of discontinuity. Okay, nobody's talking with their partner yet. Okay, well, let's go ahead and just figure out those 2 numbers, and then I'll have you guys talk with your partner about which one is which. Okay, what are those 2 numbers that make it discontinuous? 3 and -1. Okay, now talk to your partner. What is 3? Is that removable or non-removable? What is -1? Is that removable or non-removable? 3. How many people think it's removable? Raise your hand. Okay, overwhelmingly so. It is removable. How do you know? It cancels out. Good. Okay, so -1. Removable? Okay, non-removable? Correct. It is non-removable. And how do you know that? It can't cancel out. It basically is what's left over in the denominator. All right, so now, removable makes what? Removable makes a hole. Non-removable makes the vertical asymptote. All right, recap. To figure out if something, whether it's continuous or discontinuous, we look at the denominator. Okay, if it's not factored, we have to factor it. Next, we look at the x values that will make it undefined. And then we characterize it. There are two kinds, removable or non-removable. Removable means it cancels with the numerator. Non-removable is it doesn't cancel with the numerator. Okay, let's look at one example. Okay, we have this thing. We have to identify everything about it. What is the first thing we need to do? Factor, very good. X plus 3, x minus 1, x minus 3. All right, again, with your partner, I want you to decide where are the points of discontinuity and what kind are they? Where are the points of discontinuity and what kind are they? Okay, talk to your partner. Let's try Josh. Where are the points of discontinuity? 3 and 1. And Rula, what type are they? Rula. They're removable. Non-removable. Are you sure? Okay, they are non-removable. Okay, so then what is the domain? Remember domain, we look at the denominator, so x is not equal to 1 or 3. It's always the denominator. All right, next part. Question? No question? Okay, if you guys have a question, just raise your hand. Okay, why? Because she's like, okay, y-intercept. Y-intercept is when what is 0? Okay, x is 0. So then what we want to do is just plug in 0 for x and find y. 0 plus 3 over 0 squared minus 4 times 0 plus 3. That is 3 over 3, which is 1. So it's just 0, 1. Of course, you're not going to do this every single time. It's a kind of a waste of time. If you look at that equation, all the x's are going to be gone, right? Because they're all zeros. It's just 3 over 3. Yes? Okay, saves a lot of time. That's y-intercept. Good? Okay. X-intercept is when what happens? Y is 0. Okay, this one's a little bit trickier. Make y 0. X plus 3 over x squared minus 4x plus 3. How do you solve that? Yes, that's the answer, but how do you solve this? No, you don't want to look at the denominator. How do you solve any kind of fraction? Multiply, yep, multiply everything by the denominator, right? So this is 0 times x squared minus 4x plus 3 equals x plus 3. Well, 0 times everything is just 0, so 0 is equal to x plus 3. So x is equal to minus 3. So minus 3, 0 is the x-intercept. Of course, you don't even have to do that. Let's think about it logically. What will make this whole fraction 0? When the numerator is 0, right? That's the only way this whole thing can be 0. Because 0 over everything is 0. That means we only care about the numerator. As long as the numerator is 0, everything is 0. Does that make sense? So that it has to be negative 3. So that's kind of the shortcut. If you can't remember it, just do the whole thing and at least you will have the answer. All right, that's that one. Let's try another one. Okay, let's have you and your partner do domain and location of discontinuity. This is a trick question. That's why do it with your partner. Okay. So this part can't equal 0, right? Okay, try it. See what makes it equal 0. Okay, I, right? Plus minus I. Plus minus I, is that real number? No. So there's nothing that would make it equal 0, at least in the real number realm. Only imaginary numbers, but we don't care about imaginary numbers. They're not going to show up on the graph. So the domain is no solution? The graph doesn't exist? No, all real numbers. It's not, if the domain is all real numbers, what kind of discontinuity is it? Continuous. It's continuous. So it's not continuous. All right, let's have you guys try x-intercept and y-intercept. All right, y-intercept. Y-intercept is when x is 0, so y equals 0 minus 5 over 0 squared plus 1 is minus 5. So this is 0 minus 5. X-intercept is when y is 0, or really just the numerator is 0, so x minus 5 is equal to 0, so x is equal to 5. 5, 0. All right, let's try one more. This one is really tricky. Okay, again, let's have you and your partner do domain and location of discontinuity. Okay, no matter what you do, you always factor first. So this is x minus 4 times x plus 1 over x minus 4. You can see that it cancels. So that domain is not equal to 4, but that 4 is a removable kind. Okay, y-intercept, easy. 0, 1. X-intercept, okay, this one's really tricky. So x-intercept, if you look at it, there are two numbers that will make it 0, right? Because the numerator has two factors. However, one of them is going to make a whole. That whole cannot be a 0. So then what you actually have to do is find the reduced function, which is just x plus 1. So cancel out all the factors, the leftover, and make that equal to 0. So the x-intercept is only minus 1, 0. So this is the tricky part. The x-intercept cannot be a whole. So whatever was the whole cannot also be on the x-axis. All right. Let's just give you the definition, and we may do a little bit of practice. Okay, so vertical asymptote is the invisible line, vertical lines that the graph does not cross. Okay, only when the denominator does not cancel with the numerator. Okay, that is the vertical asymptote. Okay, so homework tonight, you're only going to do up to vertical asymptote. I think the homework does have horizontal asymptote. You're going to skip that for now because it takes a little bit of time to go over that. And I don't want you guys to be confused, so we're just not going to do that for now. Okay, so that is it for notes today. Let's do some practice. Huh? Wait, what? Okay, so that's it for that.